recording. All right, so we start recording. And y'all tell me, what question do we start with? Oh, for reals?
I don't have one.
What?
Dude, I asked like 5 yesterday.
You did. You did. That's fine. That's fine. That's the point. Like, otherwise, I'm gonna just move on, and you don't want that.
This is a very small administrative note. I think you scroll to the top of that page.
This page?
Like all the way up.
Yeah, yeah. Oh, okay. Hold on. My mouse went crazy.
You click on all assignments. Or sorry, all chapters.
Oh.
And you do specific chapters.
Oh, that's us. And then ours are.
Keeps you from having to scroll all the way.
Thank you for the administrative updates there. I like that. So you tell me. Give me some more questions. I don't want to make them up. Come on. Oh, okay. That's good. That's good news.
All right, I'll think I have something.
Yes, anything.
Which section? So give me a second. But section 4.
Yep.
Doing the matrices.
Oh,
Right, so
oh, the determinants at the end?
Yeah.
Yeah, let's do that. I love that. These guys.
Yes, sir.
Perfect.
Are those going to be on the quiz?
The
Or not the quiz,
no, that's not a testing. That's not for testing. No. If there's something that I say no to and I'm being recorded and it's on an exam, you get free points, okay? I'm just saying that right now. Like, because you know I forget things, huh?
So I'm curious, we all need to be quiet, wait till after the exam, and then mention it to Chad.
You would get points, yeah. So, on the homework, because this is not an exam thing for sure, you could just use Desmos, and I'm just going to remind you how to do this side of things. The by hand is cool. I'll do that as well here in a second. First, we create a new matrix, and this one, just put in my numbers. So that's pretty straightforward. And then you go DET of A, and you're done. That was it. Wow, that was fast. That's good though, right? Again, I don't want this on an exam. This is not exam worthy kind of question, right? We use determinants if you want for cross product. So cross product will be on there, but not this question. Like the things that I'm thinking on the exam would be like this thing. That's exam worthy for sure. Right? Because it just says find a cross product. Might use it, might not use it, but definitely find it. Yes, that's good. Not this. Oh yeah, yeah, and it's good to practice by hand, of course. Or we were doing that one method yesterday. But let me get a blank sheet of paper for this now. So by hand is again pretty straightforward. The method is that you multiply the things that are across from one another, and then you subtract them. So -2 times the 6 minus sign 3 times the -7. So -12, two negatives make a positive, 21, 9. You're done. Cool. Very straightforward. The 3x3 is difficult. Did you want the 3x3 by hand? Yes, let's do it. One yes means a yes. So yeah, this thing's crazy. And there's a lot of ways to do it. I was taught a whole different method in high school. Like we did this in high school. Isn't that weird? I didn't learn anything. Just want to say that, okay? I didn't learn anything, but I copied from my friends, and it's whatever. But they taught me this thing called basket weaving, which it's okay, but it's not really getting to the meat and taters of what's going on here. Okay, so we got co-majors, I think is what they're called. In linear, we're going to do this in chapter 3. It's a chapter 3 thing. So I can't remember, but I think it's called co-majors. I'm gonna choose this one this time, and you can choose any row or column that you like. If y'all were wanting to go fast, I would choose these guys right here. But I just want to show that any one of these will work. These are my numbers in the front. So I got a 1 times. I'm gonna make it a 1. 1 times something, and then I got a negative 3 times something else, and then I got a positive 2 times something else. In fact, I can full screen this now. Okay, so those are my three numbers, 1, 2, and 3, positive, negative, positive, almost always. So far, so good. And what goes inside of these little determinants, right? So different color. If I'm choosing the 1, so like this guy, it's the opposite, like adjacent matrix, I guess you can say. What they do in like textbooks is that they'll cross through like this and say, look, I've crossed through that 1, so there's your 1, and then what you didn't cross through is the matrix itself. So 4, 0, 0, -2. The problem with that is that I now can't, I have to erase it. So yeah, yay, it basically worked. Colors. Okay, there we go. So let's do it again, right? If I'm wanting that 3, I'm going to say, okay, this and this. And so there's my 3, right? And then the leftovers will be right here and right here. So -4, 0, -5, -2. Is that making sense? Then one last one. It's close enough. And so this guy right here, the 2, there's my 2. And then what's left over, -4, 4, -5, 0. And then these are just like mini determinants, right? We've already seen this stuff. So you multiply and do it. So 1 times -8 minus 0. -3 times, I got an 8 minus 0, I guess. And then, yeah, I got a 2 times 0 and then plus 20. So -8, -24. Y'all are confirming here. Positive 40. 16 minus 8 is just 8. I don't trust my math. But let's just see. So 8 is 8. Okay, cool. Yeah. And that is way long. I mean, it's good to practice for sure. But yeah, to do all this would be nuts. Another reason why I'm wanting to choose that top one right here is because when you're doing cross products, they do the IJK up here, and then simply got like 1, 2, 3, -1, 0, 4, something like that. So then these are your co-majors. So you would have I, J, and K essentially. Boom, 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 you're done, right? That's the idea behind it. So cool. But we're not doing that today. Good? Yeah? Give me some more. I'm here for you. Anything. The lab? The lab! We need to do the lab. We can do the lab right now. Did you want to do, I mean, right, exactly. Do y'all want to do the lab? Okay, cool. I'm just demoing it because, you know, I can't give you the answers, but I can at least show you the progress and process what to do. And then, like, tomorrow, if y'all want, we can, like, continue on that. Or maybe, like, y'all try some stuff and ask questions. Or maybe I can, like, I don't know. It's just, it's hard. I can't record the answers for the lab. Okay, that's the problem. But I do want to show it, so it's kind of a weird middle ground there. So yeah, let's talk about labs. I love labs. They're great. Now I made the labs a semester or 2 ago, and I've already had one set of folks go through it, and they didn't complain too much, so that's nice. So this is the first one. It is probably one of the more difficult ones, I would say. The other ones are a little bit more down to earth, but this one, it's at least geometric. And I was mentioning this in class at one point, wasn't I? Where we have a triangle, a polygon, and you're wanting to see if a ray is going through it. So here in this case, we're just saying, hey, is there a plane and a line going through it, right? And they give us the numbers, and they basically just say, what's the plane equation, and then what's the line equation, and then where is it intersecting, blah, 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 okay? Cool. So let's talk. Let's do 2 different results. So we have a plane and we have a line that's going to go through it. I'm at least going to tell you that they're not like parallel. So you're going to have something that's going to touch, okay, at some point. And this is that point F, I think is what that is, point F. And here we got point A. No. This is point ABC there. And this is DE, essentially. Something like that. Okay. So at some point, it will definitely collide. I just want to know when. When? T equals. Right? Thus, when I make my equation for the line, I need it to be parametric. So parametric for the line. I'm going to do line. Line equation is parametric. Line equation. What does that look like? X is equal to x naught plus, I don't want to use A. I want to use like slopes and stuff, but it's tough. I'm going to use A. I don't really care now. So, this would be the line. Okay, let's try that over again. So this is essentially my line equation here. I've got to fill in all the pieces, of course, right? But what we have are our slopes, and we have our intercepts. I don't like intercepts anymore. Initial points. We have a point. I'm going to write a point. I don't want to give away some of these, but I kind of have to at least get you started. Does that make sense? I have to do something. So if you don't mind, I'm going to just halfway give you the answers. Wow, thanks, John. So we're talking D and E, right? Well, D, if you see, is 0, 0, 0. And E is at 5, 7, 8. Sweet. Thank you, Chad, for integers. So I'm wanting to know what goes in all these spaces here. Like, in fact, you can pretty much get the answer just right here, right now. What do you think the initial point would be? Just take a guess. D and E. Which is your initial point? What would you put here for your point? Oh, okay. I don't want to have that recorded, but it seems like you got it. They can't hear you. Can you hear them ever? When you're listening, can you hear them? Somewhat. The answer was definitely not just 0, 0, 0. If I'm wanting to make a slope out of this, and again, slopes is like how much distance we've traveled. This is a very simple one too, right? What would that be? From 0, 0, 0, we're going out to this dude, right? So what would your x slope be? There it is. And then, giving you the answers. Y'all are getting you the answers. I have to delete this one from YouTube. So the numbers will change next semester. Boom! That's what it is. So y'all are good. We're going to just keep cruising. This is your answer, literally, to number 2. It says, what's the equation of a line in parametric form? It's right here. You don't have to have any of that. This is your answer. So how would you write that to make it look pretty? You could do it like this, or you could say just the 5t, but you're going to write with commas and stuff like that. You want to put all that information up there. Whatever you want. Either way is fine. With the zeros or not the zeros, I totally understand. Cool. Great. So we got the line equation. We need the plane equation. So that's going to be the next jump. Like I'm doing part B first. Do you know why I did part B first? Because it was easy. Okay, refresh. Are y'all good with that? Can I erase it? Okay. So it says, what's the plane equation? And they give us A, B, and C. So we got an A, we got a B, and we got a C. And we're trying to find the normal vector for this guy. Again, that's normal vector is representing that plane. It's kind of like it's the answer to the plane, right? I need the numbers for that normal vector in order to do stuff, right? But this is really deceiving. I gotta say, having it look like this is kind of not the way it should be, not in your brains. What if instead I did this and this? I like that better. Okay, so from this point, we have three vectors coming out of it, right? We have our AB vector, we have our AC vector, and then we have our normal vector. And the normal vector is orthogonal to both of these guys. That's kind of the point there, is that it's supposed to be different. Orthogonal, perpendicular. How do we find an orthogonal perpendicular vector? Product, cross product. So your normal vector is your AC vector, or AB, technically. AB vector cross your AC vector. Yep, there's your formula. In order to get AB and AC and stuff like that, remember that each one of these vectors is terminal minus initial, right? So terminal minus initial for each one of these guys. So it's kind of like I'm saying B minus A. I'm going from A to B. I'm going from A to C, so it would be C minus A. That's kind of like the vector, I guess you can kind of say, is what we're wanting to do. You help me then. What is B minus A? Oh yeah, you already did it, exactly. And then 6 minus that, right? So then, yeah, -4, 2, and 3. Am I correct? B minus A? And then cross, and then I do it again for the other one. And then you can find the cross product. That's just math, right? I'm not going to, no, don't tell me. Don't let the folks know. We already did most of the work for them. I know you're the only folk at home right now, but I'm thinking next semester. Yeah, but I might forget, so I forget stuff all the time. Totally changing numbers. I actually do have 4 or 5 sets of numbers already pre-computed, so I can change them out at will. But yeah. Anyways, so yeah, cross product. Well, like, what would I get out of this? You're gonna get some numbers. I don't really. I'm just gonna make something up. 1, 2, 3, something like that, right? This is not the answer, but you get the idea. It's just numbers. Well, this is telling you what that plane equation looks like, and so you're gonna have a 1x plus a 2y plus a 3z is equal to blah, right? That's your plane equation right there. Plane equation, and it comes from that normal vector. Like, that's how you find it. How do you find this blah? You remember? Plug in a point. And what's an easy point to plug in? Whoa. A. Yeah, plugging in A. So you would plug in your 1, 2, 3. I know that's coincidental right there. But anyways, you would plug in your A into there, right? 0, 0, 0 is your line point. I mean, it might still be on the plane, but I wouldn't guarantee it, So you plug in a point. It could also plug in this one or that one, either one. You're going to get a number, and everyone's happy. So there you go. And if you plug in any one of those 3 numbers, you should get the same answer regardless. Okay, you should get D, the same number every time. So now it's basically question 1. Okay, so what we now I'm going to refresh. If y'all are ready, I can clear it. Yeah, I can wait. I don't mind waiting, for sure. You just tell me when. I'm just gonna summarize and recap here. Thank you. I'm gonna just, it's all gone. So let's recap. So what we have is our plane equation, which was, I'm just gonna make up some stuff. Ax bycz equals a d, something like that. And then we have our line equation, which was x equals, and again, I'm having to use the same letters, lowercase this time. It looks like this. So this is just the recap, and we already got the numbers for the second one. So that's kind of like a recap of 1 and 2, right? Put in your numbers, you're happy. So question 1, question 2. Now, question 3 is we need to see where they're colliding, right? I want to know when this equals that. When are they equal? That's the goal here. And what would you do then to go and find when they're equal? Any ideas? Don't overthink it.
Oh, you should just plug in X, Y, and Z.
There it is. Exactly. This X is right there. This Y is right there. This Z is right there. And so it's going to look a little messy, but A times, and just I'm plugging it in now, it would look something kind of like this, plus B times Y naught BT, C times Z naught, Z naught plus CD is equal to D, right? We plugged it in. Plugged in our X, plugged in our Y, plugged in Z. All these are numbers. Everything is a number except for T. T is the only thing that we don't have. So out of this, blah, 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 T equals, and you're going to get a number. Again, that's telling you when it's going to hit the plane. When. Which is good. We like that. So this is when, but I'm wondering where. How would I get that out of that T value? I have the T, I know when, but where? How do I do that? There it is. You plug it back in. You already have this line equation. And so like this is the answer again. So your X would equal, and then it's, X naught plus AT. But this T is the number that you put in there now. So everything's just numbers. You get a number and you're happy. Do it again for Y. Do it again for Z. You get your numbers. There's your point. You have your, and this is F. This is called your F point, by the way, the X, Y, Z point, where they're touching one another. So, yes. So you plug in your line to the plane, solve, and then you plug in that number into your line. And you're done. That's question 3. Again, I can't give you answers, but like, there it is.
I don't know, knowing the process just makes it a lot easier.
Oh, yeah.
Ask,
Yeah, and they meaning me.
Get a lot of confusing labs, Chad.
Yeah. No, I know. I think I cleaned these up a lot. The ones before all this were nuts, but yeah, these are moderately better. So, good with the process, right? Line into the plane, solve, and then that number into the line, and then you're done. Just plug it in. Do I refresh? I can wait. I don't mind at all. So question 4, I've got to say, is going to be the hardest one because there's lots of techniques to doing it. Last semester, I had a lot of folks use interesting methods, and most of them got it wrong. But I can at least tell you that it's a Boolean answer. It's either true or false. It's yes or no. It's multiple choice. So 50% chance you get it right by just guessing. Yeah, basically. So it says, is this intersection point inside or outside the triangle? And that's it. It's either inside or it's outside. That's it. So random chance you're going to get it right by just rolling the dice 50-50. But like, of course we need to do the math, right? I'm going to give you one technique because it says describe the method that you used. That's actually interesting. If you can justify that, yeah, I like that. That's actually clever. Well, now I'm rethinking me doing math. Maybe I just graph it. Oh man. I'll let you graph it. I want you to justify that. That's good. You're good? Okay. So refresh. Here we go. So it's not just a plane, like we were talking, a line going through a plane, right? And that's my point F that I just found in question 3. It's not really that. It's a triangle in specific. And we're trying to say, is it inside this triangle? We know it hit the plane. Everybody knows it hits the plane. But did it meet that triangle inside of there between A, B, and C? What I do is I kind of break it down into 2D. So we got A, B, C, and then we supposedly have an F somewhere on the inside. Supposedly, okay? Let's just assume that for a minute, right? If F is in the inside, then what I have is 3 little triangles, yeah? And these 3 little triangles make up a big triangle. So this is just one method. I can say that the area of this one and the area of this one and the area of this guy, total area, so A1 plus A2 plus A3, is equal to your total area for the entire triangle, which would be like this guy. Can you find the area of a triangle in 3D space using formulas? There's a formula for that, right? It's something cross product dot something blah. I don't know, but I mean it's out there. Can you find the triangle, these little mini triangle areas using the same formula? Technically, if you're looking at just this one, like let's just zoom into this triangle right here for a second, you'd almost have to like recreate some of it. This is B, this is A, this is F. Can you make a vector, and then now you have 2 vectors? You can do like a triangle formula thing, right? Cross product dot something. I don't know. I can't remember, but right? Cool so far with that? So that's one method. You find the areas, and they should make the total area if it's on the inside. But what if it's not on the inside? What would it look like? And so let's do an example where it's not on the inside. And I'm just going to do it on the side over here. So let's say I have my triangle, ABC, and I have F outside of the triangle. And what if I do the same process? So here's my same process now with this new triangle. I got ABF, right? There's one triangle right there. This triangle alone, this is A1 right here. There's A1. That one alone looks bigger than the total already. You see what I'm saying? When you add up all 3 of these, it either equals the total or it doesn't, or it basically exceeds. I don't think you would ever get under. It would have to be exceeding, and that's only one triangle. Like we have this triangle here, right? So there's my A2, and then I still have this triangle right here, A3. You can see that the total area of those 3 little ones is way bigger than the other guy. So that's what I'm looking for. I would say the area method is saying my 3 little ones are not the same as the total. And then that's a bad thing. That's like outside. Make sense? What I've done in the past, nobody wants to do that. So it's like, wow. Oh, I thought you had a comment about it. Yeah, from pre-cal, right? I mean, so I'm one to kind of revert back to the basics, and so I use Heron's a lot. But we have cool formulas now that we can do this. Just a thought there. Graphing it was a really great idea. There's other methods, of course. I had somebody last semester did some funky math, and it worked. And I was like, okay, fine, I don't care. So there's might be a formula out there I just don't know about. So yeah. And then number 5 is just a talk, and that's how all the labs will be. There's 4 actual questions, and the 5th one's just discussion. So talk about it, put your own words, that kind of stuff, right? I just want to make sure you're not copying from Wikipedia much. So, but it's, you know what I mean? It's just talk about it, make it real. Cool? Go ahead. Oh, yeah. Well, kind of I can. I'm going to say hopefully, because what I did, it's been years since I did it, but Heron's formula in 2D is A plus B plus C all over 2, and then your area is square root of S minus A, S minus B, S minus C. What these A, B's, and C's are distances. And so I'm going to use a different color here. This distance right here, like this distance, that AB distance, that would be like A or something. And then you got this AC distance, would be like your B, basically. And so if you have all three of these distances, then you could just kind of like mush it all together and get an answer. I prefer Heron's because it's formulaic, and for Chad, I'll give you the secret. I actually have an account with Desmos where it has all the answers already pre-built because I put in the formula and I used Heron's, so that it could just go boop 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 boop, and I just get the answers in Desmos. Heron's is very nice because it's just a formula. You know what I mean? The other ones are formulas too. I just didn't think about that. So, yeah, cool. Yeah. Oh yeah, that always works. It just takes a long time to do. So, because the strength of these here. Let me go to those formulas over here. Look right there. I'm already on it. So to find the triangle, you're just like cutting that in half, right? Wouldn't it just be like that divided by 2? Super, because you're just doing this. So there's your triangle right here. The strength of this is that it's like already kind of done, I guess. It's something very recognizable, very simple. But here, you'd have to find the distance of each one of these. So you have to make the vector, and then you have to find its magnitude. Find the vector, find its magnitude. Find the vector, and find its magnitude. It just takes forever. But either way is fine. Cool? Concept-wise? Awesome. And I did not give you all the answers. I gave you most of them, basically. Any other general questions about the lab? I can go back and talk about something.
So hear me out, Chad. Question 4.
Yeah.
Can we say yes purely by the graph that they give us shows that it goes through the plane?
No. Should I put that up here? This graph is arbitrary, blah, blah, blah. Yeah. I mean, yeah. You can see I use, like, paint to make it, okay? Yeah.
Description, not actual,
Thank you. Thank you. Anything else? Good? Good description? Cool. Okay. Go ahead.
So Heron's is going to give you basically that it is inside, or that the area is.
It'll give you the area of a triangle. So Heron's will give you this number, this number, this number, and then this number, but all separate. So you have to like pre-compute all the, like get it all ready, and then boom, you got a number. Boom, you got a number. And then you just compare them. You're adding all these guys. Is it the same as this one? No, and of course, look, we're using Desmos, right? It's going to be off by a decimal, probably. I don't care. That's fine, okay? If it's anywhere close, then it's probably fine inside, right? If it's off by a lot, then yeah, that would be bad. But like as an example, if we got 100.2 and this was like 100.5, that's fine. We're good. It's inside. Let it go. Okay.
Rounded up whole numbers here.
I'm okay with that. Yeah. I mean, because it's just, the calculator's not going to, there's rounding and all this other stuff going on. Even if you got like 101, I'd probably think that's fine. If you're telling me, doesn't it say there on number 4? Describe what you're doing. You say, I think it's inside because you Chad, said 100.2 and 101 are fine. I'd say, okay. This, I would get a little suspicious if it were like this. That's just getting suspicious. If it were this, that's bad. That's definitely bad. So, cool. Okay.
Just to clarify one last thing.
Yeah.
So the total area is taking A, B, and C.
Yes.
The area A is like taking A, B, and then finding the F point, right?
Correct.
Okay.
Yeah, ABF, or BCF, and ACF.
Okay.
Yeah, always around F.
All right. Thank you.
Good. Cool. Any other questions? Okay.
So will this method actually tell you where the point ends? Just that it does.
just that it does. You already know where it hits, technically, like in space, right here with question 3. But distances from those points you would have to go and do individually and stuff. Yeah, that's actually another cool method. Here, real quick, let me just. I was just thinking out loud just a second. Is it might be a lot faster. The distances to these points are like small, but if it's on the outside, then the distances are bigger. The problem with this method is that some sides of the triangle could be really oblong, I guess, or what you obtuse, I don't know what you call it. But anyways, some of them could be way longer than others, and it might skew it a bit. And especially when you're really close to the edge, it might not be easy to determine. But that is another easy method if it's like blatant. You know what I mean? Like if this one's like so long, it's longer than any of the other sides, then like there's no way it's inside. Perhaps I'm going to leave that one for academic freedom. Sure. Yeah, everyone has their own ways of doing it. Graphing, see, that was an awesome idea. Everyone has a different way of going about it. Cool. Great suggestion. Thank you for the lab. That was great to suggest it. Any other questions on the homework? Anything that popped up maybe? No? I mean, we got 20 minutes. I could definitely keep going. You're finding something now. Let's find something, guys. I can't even remember 13 when I wasn't prepared for it, but oh, this is so easy. This is so easy. It's silly. Let's do it. I want to do it. And if y'all have other questions next time on the homework, anytime, really anytime, not just during these days, you tell me. I pull it up. You know what I mean? I'm here for you. Let's do some of this. This is so easy. And I mean, this is actually going to make you feel better about this class because you're like, hey, look, derivatives. Forget this limit junk. We're doing derivatives, right? So you have your position. I'm just going to give you some of these definitions here. Position is your R vector. Velocity, of course, is going to be a V. And acceleration is going to be an A. So the only one that's a little different looking, can I zoom in a little bit there? Yeah. The only one that's a little bit weird looking is the position, and we use R. R means radius, but it's not radius from a circle, it's radius from the origin. So like here, going out, we would say that's R, going to like a point P or something like that. So you can think of it kind of like radius, that's what I do. It's just from the center. And you're going to be seeing R of t all the way through the rest of the class. All the way into chapter 16. You're going to be still using this thing for the rest of the class. So get comfortable with R. It's just a position. Again, these limits are scary for no reason at all. I don't even remember doing limits. So it's not a big deal. But derivatives we can do. So are y'all okay with just the terminology, right? The velocity acceleration is pretty plain. Position's the only one that's a little weird. And I mean, see, you can see that R vector again coming from the origin out to a point P. It's as if I knew what was going on here. Wow. Of course, they got really cool loopy thingies going on and stuff. We'll get to that later. So to do the math side of things, and I don't even know where we're going with this, to do the math side of things, we're going from the position, our position, and we're wanting to find its velocity. What do we do? What's the math to go from here to there? Derivative, you got it. A derivative. And from velocity going to acceleration, what do we do? You got it. You got it. Derivative. So, I mean, we're happy derivative land. That's easy stuff. Now I'm going to ask a way hard question. Not really. Acceleration to velocity. What do we do? Man, it's as if y'all had Cal 2. I know, right? Well, it is. This is a recap on Cal 1, basically. That's what we're going to do. I don't think we're going to do integrals right now, but they might come up. But yeah, basic derivatives and integrals going back and forth. That's all we're doing here, right? So I don't even want to read the rest of the question. I just want to do it. So they have this, and I want to do some derivatives. So V is my R prime, and let's just do this thing. I want to keep it in vector land. What's the derivative of t minus 1? 1. That was so boring. What's the derivative of t squared minus 5? Man. Are y'all feeling at home here? Right? Is this nice? And so then my r double prime would be my acceleration. What's the derivative? And then here? Got it. You got it. Cool. I haven't even read the question. I just know that's what I wanted to do. It's really fun. Fun derivatives. Okay. So this was a two-dimensional vector. What if I put a k in there? You think you could do the same thing? Probably. It's the same thing. Do it 3 times. So what are they wanting here? It says the equation of the path of the particle is y equals something. I'm not really clear on that yet. We'll go back and read that here in a second. Here, they're saying what is the velocity at t equals 1? What's the acceleration at t equals 1? This is much more clearly defined. If I were to plug in t equals 1, what would I get out of that? And if I plugged in right here, if I plugged in t equals 1, I would get... All right, awesome. Just plugging it in. Good? That's easy stuff. All right, now what are they talking about, this equation of the path, blah, blah, blah? Well, what they're trying to say is that we have here is an x, and here is a y. We all agree with that, I'm guessing. Those are my x and y components. I think what they're saying is mush them together to get something that works. In a way, we got y equals blah, 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 x. Okay? Put some numbers in there, and hopefully it works. So I got x is equal to t minus 1, and I have a y is equal to t squared minus 5. I want to make it only x's and y's. That's it. What would you do? Perfect. Have you had like engineering before? Well, you know what's going on then. Have you had physics yet? I can't remember. Oh, there we go. Exactly right. Solve for t. So you got t is equal to x plus 1. I'm going to take that and plug it in right there. And notice I'm using this one right here because it's way easier. Did you want to solve for t right here? What would you have to get? Square root. And nobody wants a square root. Nobody wants a square root. That's just, yeah. You know what I mean?
I believe we also had to do this in calculus 2 with the differential equations. We had to solve for t and then plug in for x's and stuff like that. Yeah.
Cool. Now they don't say simplify, so I want to leave it that way. Now I want to see what the homework says right quick. I do have both of them, so let's go and check this thing out right quick. And they simplified a little bit. Ooh, I hate when they do that. I mean, like, why? Why? Like, okay, guys, do you know how to graph that one? I mean, you got the approximation, right? Come on, you approximately know what it looks like. But can you graph that like this? No way. Okay, hold up, hold up, hold up. Can you graph this one? Yeah, because you shifted over to the left by 1 and down 5. What is bizarre about this? Right? I know. And that's why it's just my thing that I don't like simplifying, especially in Cal 1. Because it's just... Anyways, you already know my feelings about all this. So let's get what they got just so I can confirm I'm doing it. So x squared. We got 2 x's because I'm lazy. I got a 1 minus a 5. Minus 4. It'd be a minus 4. Did they have that minus 4? I can't remember. Yeah. Yeah, there it is. That's them. Ew. But they did not say to simplify, so I would attempt at least to put that guy in first. If, and I'm serious, this goes all through the class. If it's not letting you keep it like this, you tell me. I start yelling at people. They promised me it wouldn't be that way. Okay. One or
I'll come to you with alligator tears.
yeah, please.
It's way simplified.
Yeah, I don't want it. I don't want simplify or unsimplify. Okay, blah, blah, blah. You know what I want? I want this. I want this. I want that to work. Okay, cool. We still got some time. I would love to keep going. Y'all love derivatives and stuff. Look, in fact, this is a you do. Yeah, this is a you do. Finally, yes. You do this one. I'll hang out. I'm just going to copy this bigger. I'm not actually cheating. Beautiful. Love me some derivatives. This is good times.
Cosine, sine, negative. The derivative of cosine is negative sine.
Let's do like 30 more seconds. Oh dang, you're setting it down, bro.
Yeah.
I don't ever want y'all to think that I'm going too fast or something, especially in this class. I don't want that. Especially when we're talking about this kind of thing, where y'all are doing something. I have to have a cutoff line, of course. The idea is always that, are you in the right direction? Right? Not that I complete it. Did I do what I was supposed to be doing? That'll especially be important later when we have very, very big problems. Triple integrals, you know what I mean? It takes a long time, and you wouldn't want me to stand up here idle for 10 minutes. So, direction, steps. That's what we're looking for. So, what's my derivative of sine? Cool. Derivative of cosine is? Sweet. And right here? Sweet. Cosine goes to? This guy? Yep, sorry, you're right. You're right. You're right. You're right. And then? Yeah. So they actually just want the vectors themselves. So I believe that these are your answers for A and B. Straight up, just pop it in and you're done. Notice that they have a little T saying that they want T's in there. correct. Part C, now I have to plug it in and figure out what's going on. So this, I gotta say, it's upsetting. We got 5 minutes. That should be plenty of time, hopefully. They're trying to get at the point that we have a scalar in the front, and then we have variables in here, basically, okay? I don't like this setup. I think it's too constraining, but we do have to do it because that's kind of what's going on. So they're talking about the velocity vector in particular, and at pi. So before anything else, I want to just plug that in. Plug in a pi. So if I plug in t equals pi, what would cosine of pi be? Yep, -6. So yeah, -1. So yeah, yep. And then sine at pi, 0. And then we still have a 3. This is basically their answer. I would like for them to be okay with that and be done, but they have all these separate boxes. I got to do something about it. So we're going to find the magnitude of this first. So that's 6 squared, 0 squared, 3 squared. 36 plus 9 is 45. And this guy, I think, is what's going to go out here in the front. And then we have to do unit stuff on the inside. And this is where I just dislike it. Here's my approximate answer, and then we're going to go jump to the solution that they have. I don't want orange. I don't want orange. There's too much orange. Hold on. Wine colored. My thoughts is that it'll look something kind of like this. And we're going to just triple check and see what they say. Those are my thoughts, okay? Let's just see what they got and go from there. Yeah, so they simplified it a little bit. Let me verify that 3 square root 5 is the same. So this here is 3 times 15. So that would be 3 times 3 times 5, am I right? Or is it 9? Well, 9 times 5, yeah. Hey, man, it's good to see you. So yeah, 3 times 3 times 5. You can pull the pair of 3's out. So we got 3 square root of 5. Did they have that in the front? Yes. So, okay, we got that idea. Now, notice that each one of these, there's your 0, right? But each one of these is divided by it. Same thing here. And I think that we have a -0 positive. Yep. So if I had it where, again, I'm running out of room here. If I had it where it was -6 divided by 3 square root of 5, wouldn't these cancel a little bit? Is that what they had? Right? Flash it. Yeah, see? It should accept this stuff right here. It should. It better. Again, that's that same point where it better do the right thing. Because, yeah, that's what we were promised. That's what I was promised. Make sense, though? Okay. So, like, find the magnitude, divide it by that. It's super dumb, but whatever. All right, we're done. Thank you, guys.